Estimating the storage capacity of the human brain in terms of terabytes is a complex and somewhat speculative endeavor because the brain's information processing and storage are fundamentally different from digital devices. Nevertheless, we can provide a rough estimate. The brain doesn't store information in the same way a computer stores data on a hard drive. It relies on the strength and connectivity of synapses, which are the connections between neurons, to store information. Each synapse represents a connection between neurons, and the strength of these connections can be adjusted through a process called synaptic plasticity. This allows the brain to store vast amounts of information through the varying strengths of trillions of synapses. A rough estimate of the brain's storage capacity can be based on the number of neurons and synapses. The human brain contains approximately 86 billion neurons, and each neuron can have thousands of synapses. If we assume an average of 1,000 synapses per neuron, we get a total of around 86 trillion synapses. Now, estimating the amount of information stored at each synapse is challenging, but if we make a very rough assumption that each synapse can store the equivalent of a single byte, 8 bits, of information, we get approximately 86 terabytes of storage capacity for the entire brain. This is a very simplistic estimate and likely a significant oversimplification because the brain's information storage and processing are far more complex and dynamic than this simple calculation suggests. However, this oversimplification ignores crucial factors. 1. Analog versus digital. Unlike digital storage, the brain processes information in an analog, graded manner. Neurons do not have discrete on-off states like bits, making it difficult to equate synaptic connections directly to bits. 2. Encoding complexity. Information in the brain is encoded in various ways, such as through the strength and duration of signals, the patterns of neuron firing, and the chemistry of synapses. This complexity far exceeds the binary code used in digital systems. 3. Dynamic nature. The brain's connections and information storage are highly dynamic, with constant changes and adaptations occurring throughout a person's life. In reality, the brain's storage capacity and information processing are not easily quantified in digital storage terms. The brain's ability to process and store information is a result of its intricate neural network, and it's not directly comparable to the binary storage of digital devices. Thus, while 86 terabytes is a rough estimate, it doesn't fully capture the complexity of how the brain functions as an information processing and storage system. Subscribe for more videos. Thanks for watching.